So I've split this grid into 4. I'm just going to make it a little bit smaller, otherwise we're not going to be able to see everything. So if you're taking notes, then I would like you to take your piece of paper and split it into 4 the way that I have here. And what we're going to do is we're going to fill in everything that we need to about each graph that we need to know, because there are exactly 4 graphs we need to know in grade 10. First one, an easy one, we learn about them in grade 9, is your linear function. Okay, I know you're like, oh, ma'am, really, linear functions? Yes. Okay, the linear function is quite important. It comes up all the time, again and again and again. It keeps coming up. So we shouldn't disregard it just because we're like, we did this in grade 9. It's going to come up even in your matric paper. So we need to know certain things about it. First thing we need to know is that our formula would read f of x is equal to mx plus c. I'm going to talk a little bit more about f of x in a later stage, after we've done this, because I really believe that f of x is an important concept and we need to understand it fully in order to answer questions properly, but we'll get into what each of these things mean. All right, so f of x is equal to, yes, my darling.
Ma'am, are we gonna, sorry for interrupting, are we gonna do are we gonna do measurements?
Yes, ma'am. It's going to be part of the exam revision we go through in the weeks leading up to your exams.
Oh, okay.
Okay, so it is coming up. Don't stress. All right. Okay, I'm going to continue. Okay. All right. So we know that our gradient M stands for the gradient. Let's rather do this, actually. Let's do it the correct way. M stands for the gradient. And we know that M is equal to y2 minus y1 over x2 minus x1. Okay, important thing, right? Our C is our y-intercept. Sure. Okay, our y-int, right? And we know that whenever we find the y-intercept, we need to make x equal to 0. Same thing if we're looking for our x-intercept, we need to make y equal to 0. All right. On top of this, we need to remember our domain for a straight line graph. Our domain is all the x values. But now one thing we know about a linear function is if it moves that way, it's going to go in every direction, forever in the positive direction, forever in the negative direction of my x values. So my x would be an element of all real numbers. Same as if I drew a negative graph. It's going to go forever in each direction. So it doesn't really matter whether it's a positive graph a positive graph or a negative graph. Both of them will have a domain of x is an element of all real numbers. Our range is always our y values, and our y will always be an element of all real numbers as well, because my graph will continue going up forever and it will continue going down forever. I just want to check that everybody's okay with everything ma'am has written on the screen. Thumbs up. Are we all good? Lovely. Okay, this is information we need to know about a linear function. Right, can I move? Let's keep going. Let's talk about our quadratic function. Okay, our quadratic function, right? Our quadratic function gives us a parabola. Okay, our quadratic function gives us a parabola. It gives us a parabola. And a parabola is a little bit more tricky as we go along, but let's remind ourselves of the formula. So we know that f of x is going to equal to ax squared plus, I don't know if your teachers use plus b, plus c, or plus q. We use plus q. Does anybody use anything else? Hello, Jaden. No worries. I'm just happy to see you. Thank you for joining us. Does anybody's teacher use anything different, like a Q or a P or a B? Aha, there we go. But it doesn't change what it is, right? It doesn't change what that letter is. So where I've written a Q, I just need you to write a B for me. Okay, Oko? If that works for you, my darling. All right, let's talk about what each of these things actually mean. So we know that we can get 2 types of parabolas. If our A value is positive, and I'm not going to write positive, we are in grade 10 now, I'm going to write A is greater than 0. What kind of numbers are greater than 0? positive numbers, we know that if A is greater than 0, then my graph will be concave up. And if A is less than 0, sure, it's less than 0. My pen is just deciding that, no, not today, ma'am, not today. Okay, if A is less than 0, then my graph will be concave down. I'm very sorry, guys. If my writing starts getting a little funky, it's because my computer's acting funny. All right. And then the concave down part has just gone away. All right. Oh, there it is. All right. One thing we also know is that, sorry, let me just get to this. Okay, we also know that if A is in between 1 and 0, what happens to my graph? It must become flatter or skinny. It's not a vertical shift, my darling. We're still talking about A. Vertical shift is Q. Q is going to be what moves my graph up or down. All right, so here's what happens when my graph is between 0 and 1. What kind of numbers do I find between 0 and 1? Somebody give me an example of a number between 0 and 1.
0.5.
0.5, right. It's a fraction. And what happens when my number becomes a fraction is that my graph starts doing this. It starts going like that. And it gets closer to the x-axis. So basically what it does is it flattens out. It does that. Okay. And the more it gets bigger. So if we look at a number like 3, in the A part, let me use a different color. If I look at a number like 3 there, or 4 there, or 5 there, what's going to happen is my graph is going to get narrow and narrow and narrow and narrow and narrow and narrow. And it's going to get closer to the Y. Okay. So if we find, oh, wait, guys, I don't want to lie to you. I think it's the other way around. Let me just make sure. I'm going to quickly, very quickly, just going to write here. Quarter x squared minus 16. No judgment, guys. Hey, this math stuff is quite hard. Okay. X is equal to 8. X is equal to -8. Right. If x is equal to -8, y is 0. So it does get flatter. Yes, correct. Okay, I wasn't wrong. Don't stress. I was correct. Okay, I just needed to double check. Okay, so if the number is like a 0.5 or a 0.3, then my graph starts getting flatter. It does this. It starts looking like that. If my number is between -1 and A and 0, then my graph will flatten out, but just in the opposite direction because these are negative numbers. All right, thumbs up. Everybody okay with what ma'am has just explained here? Yes? We all good? Remember, everything that I'm discussing here is just the properties of each of these graphs. And all of this stuff we must know, guys. We must know. All right, then we can talk about Q, which is nice and easy. Q is just our vertical shift, like we said before. Q is our vertical shift. So it just takes the graph that we already have and shifts it either up or down, depending on what's happening. All right. Then what we need to remember as well in this particular section is that we always have a turning point. And my turning point will always be the value 0 and whatever my Q value is. Whatever my Q value is, that is my turning point. So if you don't know what TP stands for, replace that with turning point. All right. Another thing that's going to come up in every single graph, grade 10s, is always your x-intercepts. X-intercept, y must equal 0. Y-intercept, x must equal 0. It's going to come up again and again and again. So remember that. All right. Remember to always write that down. It's quite important. Okay. And then the last thing that we need to remember here, our domain. A domain for a parabola is always x is an element of all real numbers. Why is this? Because my graph will keep going in the x direction forever. But for my range, however, my graph will always not go further down than my turning point. Okay, so my y value needs to be greater than or equal to whatever q is, if q is concave up, or y is less than or equal to q if my graph is concave down. Okay, so if a is positive, then y is greater than q, and if a is negative, y must be less than q. Thumbs up. Everybody happy? I have a feeling everybody's going to be like, ma'am, let me just take a screenshot. Take a screenshot if you can. All right. All of this stuff, super, super important. Okay, great. That is your quadratic function. Good. Silfato knows we're going to move on to the hyperbolic function. Lovely. All right. And then in the hyperbolic function, we start talking about something a little bit more complicated. We learn new things. I heard a bloop. Is that somebody's hand? Would somebody like to ask a question? Remember, guys, I'm not going to restrict your asking any questions. If you have a question, you can just unmute and ask a question. Or if you'd like, you can also just type your question in the chat and I will deal with it. All right. Okay. Let's talk about the hyperbolic function. Whew. Hyperbolic function. The hyperbolic function gives us a brand new graph. It's called a hyperbola, but this particular graph introduces something new, and we'll chat about that just now. The function of a hyperbola, f of x, is equal to a over x plus q. All right, and we are introduced to something here called an asymptote. Okay, asymptote. There we go. We have two of these. One of them is that x cannot equal 0, and the other one is that y cannot equal the q value. I just want to check, is everybody familiar with this concept? Does everybody know that? Good. So y equals a, or we say a, but you can say k, my darling. It's perfectly fine. So where I've put an a, you just need to put a k there. All right. Okay, lovely. All right. So then there are some other things that we need to figure out here. First, we need to know our quadrants. So I'm going to draw a Cartesian plane, a smaller Cartesian plane within the Cartesian plane. This is quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. All right. I know that if my a value is greater than 0, then my two hyperbolic graphs must be drawn in quadrants 1 and quadrant 3. Right. But if my a is less than 0, then my graph must be drawn in quadrants 2 and quadrant 4. So what I mean by that is the purple one, if it's positive, we will draw it here and here. And if it's the blue one, that one, we will draw it here and here, because our graph will always have two separate things because of our asymptotes. Our asymptotes kind of do that. All right, just to remind you that your x asymptote is your vertical asymptote because it touches the x-axis, which means it goes up and down. That's vertical. And your y asymptote is always your horizontal asymptote. If you've forgotten which one is which, just do this in with your hand and see which graph or which axis the graph is going to cross. If I do this, I know that my graph is going to cross the y-axis. So that's my horizontal asymptote is my y-asymptote. If I do this, my graph is going to cut, or my asymptote is going to cut the x-axis. Therefore, my x-axis or my x-asymptote is my vertical asymptote. All right. And it's helpful that we don't really have to remember that it's vertical and horizontal. We can just do a quick hand test if we want to. And now it looks like I'm trying to, you know, summon up Gojo's demons or something. I'm just kidding. All right. Okay. I'm missing something very quickly. Again, we are always going to look for the x and y asymptotes. Now, the thing about this hyperbolic graph is that it's never going to have a y asymptote. Not asymptote, intercept. The reason why there's no y-intercept is because we can't touch the x, sorry, not the y-intercept, the x-intercept. One of them. I need to figure out which one. Okay, remember x-intercept y will equal 0. Okay, we will have an x-intercept. We just won't have a y-intercept. Okay, no y-intercept. And the reason why we cannot have a y-intercept is because in order to find the y-intercept, we would need to make x equal 0. But we've already said here that x is going to be problematic if we make it equal to 0. So no y-intercept. Does everybody understand why ma'am is saying? Correct. It's the dotted line. Okay. Are we all happy with that? We have an x-intercept. We just don't have a y-intercept. It's important that we remember that. Okay. And I have not forgotten, grade 10s. We must always remember the domain and the range. My domain is going to say that x is an element of all real numbers except x cannot equal 0. We've already said that. X cannot equal 0. My range, because my range is all my y values, y is an element of all real numbers except y cannot equal my q value because that's also an asymptote. Therefore, my graph of y cannot cross there. All right. Are we all good? I'm going to give everybody 5 seconds. If you're taking screenshots, go ahead and take a screenshot. Shot. 3, 2, 1. Oh, fortunate, I can add dotted lines for you. I'm so sorry. Okay, let's add some dotted lines. The dotted line will go down like that. And the other one is a Q dotted line. So it can either be at y is equal to 0. It could be there. It could be there. It depends on which part we're drawing. So our asymptotes are always drawn with dotted lines. Just remember that. That's how we know that they're dotted lines. Okay, let's talk about the last graph, which is your exponential graph. Okay, your exponential graph or your exponential function also gives us an exponential graph. Okay. Okay, sure, Tsirofatso. Can I finish up here quickly, my darling, and then I'll scroll up for you and you can take a picture. Yeah? Once I'm done here. Okay, lovely. All right, so our exponential function says f of x is equal to a times b to the power of x plus q. And we know that it's an exponential graph because our x is the exponent. That's how we remember that it's exponential. If x is the exponent. All right, here's a couple of things we need to remember about this. Right, a cannot equal 0. Okay, b cannot equal 0. And b needs to be greater than 1. Okay, that's the things that we can remember here. All right, b needs to be greater than 1. Okay, those things are very important. Okay, who can venture? Why does ma'am say a and b cannot equal 0? Why is that important? Who knows? Anybody want to venture a guess? I'll give you guys a hint. Take a in your answer there and replace a with 0 in that function. What happens if we make a 0 in that function? What I mean by that is do this. Go 0 times b to the power of x. What happens if I replace a with 0? Anybody? Nobody?
Like root of x.
Say
Won't
that
that make
again, my
the
darling.
b and the x 0?
Yes, exactly.
Like it's gonna
Because
be okay.
keep going.
Like it's gonna be 0 times b to the power of x. Won't that make the b to the power of x also 0, making the sum basically useless?
Exactly. Spot on, my darling. Just wow. Absolutely. If I make a 0, everything will become 0. And then I won't have an exponential graph anymore. Oko, you are a whole genius. I don't know. I just mean, I always knew it about you, but I feel like you needed to know that just, once or twice. Right. If I make a 0, it doesn't matter what b is. Whatever b is, if b comes out as 4, 4 times 0 will give me 0. If b comes out as 3, 3 times 0 will give me 0. If b comes out as 5, 5 times 0 will come out as 0. So will I have an exponential graph if I make a equal to 0? No, because everything will just be 0. And so there's no point in us making a 0, right? Same with b. If I make the b part 0, everything will be 0. Okay, thumbs up. Does everybody understand what I mean? Are we all okay there? Yes, that's why a cannot equal 0, and that's why b cannot equal 0. Because if we do, then we no longer have an exponential function. We've got a straight line, basically. All right, so we need to make sure that we're understanding that. All right, the reason why b needs to be greater than 1 is because a does the function of b being a different number. Okay, sorry, b needs to be greater than 0, not greater than 1. B needs to be greater than 0. It can be a fraction. Okay, B needs to be greater than 0. If you're taking notes, I'm so sorry. Please switch that to B needs to be greater than 0. All right. All right. So I've lost my train of thought. It will come to me. It'll come to me. All right, great. A cannot equal 0, B cannot equal 0, B needs to be greater than 0. The reason why we don't care whether B is a negative number or whether it needs to be a negative number, because numbers greater than 0 would be 1, 2, 3, 4. What about all the negative numbers? If we want a negative answer, all we need to do is make a negative. And then what will happen is whatever answer we get for b to the power of x, we'll just multiply it with the negative from a, and my function will then become negative. Thumbs up. Everybody understanding why b needs to be greater than 0? Yes, because whatever answer I want, if I want a negative answer everywhere, I can just make a negative, and whatever answer I get for b, I will multiply that with a, okay, which is the negative number. Of course, Jaden, just wait for me to finish, and then I'll let you guys take all the screenshots you want. All right. Okay. All right, so that's why A is important, just as important as B. They work together in order to make that happen. All right, we also still know Q is our vertical shift, but Q is also something very important in this particular graph. Q is our asymptote. Exponential graph also has an asymptote of Q. Asymptote Y cannot equal Q. Y cannot equal Q. So that's also very, very important. We need to remember that. Okay, let's talk about what A does, because A does a lot of things. Right, if A is greater than 0, so if it's positive, then my graph will go up like that. It will increase, or it can also increase in that direction. Let's talk about when it increases in the different directions. Okay, if it's increasing towards positive x and positive y, it's because my b value is greater than 1. But if it increases where the x's are negative and my y's are positive, it's because b is in between 1 and 0. All right, that's when it increases. If my a is negative, greater or less than 0, then my graph will either go down like that, so towards the negative y, or it will go down in that direction towards the negative y. Again, for the exact same reasons, because if the b value, let me just write this in between them because they both share the statement. They both share the statement. If the b value is greater than 1, then it will increase in that direction. If my b value is between 0 and 1, so a half, a quarter, a third, then it will go in the negative x direction. All right. Again, I did not forget my domain. This is a lot of information, grade 10s. My domain x is always an element of all real numbers. Oh, that's ugly. Let's try that again. X is an element of all real numbers, and my range, y is an element of all real numbers, except y needs to be greater than my asymptote, or y needs to be less than my asymptote. And all of this will be determined on whether my a is positive, and that one will be determined whether my a is negative. All right. This is all the info. That was a lot of info. Whew. Oh, all right, shall we take screenshots? Let's start at the beginning. All right, Teofato, here we go. Here's the first part, the linear function and the quadratic function. Okay, everybody take screenshots, 5 seconds. 4, 3, 2, 1. Yeah, it did. I know, Desmarie. But you know what? It's important information. So it's quite important that we know all of this. All right, here's the second half of it, your hyperbolic and your exponential. 5 seconds. 4, 3, 2, and 1. All right, can I get started? Is everybody ready? Can we put some of this to practice? Thumbs up. We all good? All right. Okay, so I'm going to keep saying this, grade 10s, over and over and over again. I'm going to remind you guys that the most important thing to do whenever we get into a question or into an exam is to read the questions. I'm going to start you guys off with something nice and easy. This is just multiple choice. There are 5 questions. This one should actually say E. Clearly, I can't type E. So here are the questions: A, B, C, D, E. I'm going to give you guys exactly 5 minutes, okay, to answer this question. I just want to make sure. Sorry, this over here should say ax squared plus q. All right. And then this, the q represents, sorry, this is from a grade 11 paper, but it's still relevant. 5 minutes, peeps. When you're ready, pop an emoji on the screen, or you can type done in the chat. Also, guys, please don't guess. Please don't play eeny, meeny, miny, mo with the questions. Please, let's take them seriously. Because that's what my kids do. They just close their eyes and they point. And whatever they land on is the correct answer. No, it's not. Please pay attention. Last minute peeps, let's finish up. All right, ladies and gents, are we ready? Can I look through the answers? Yes, or are we still kind of sort of figuring it out? Some of these are quite easy, some of them not so much. Okay, let's start. Yes, Kakeho, we will. Yes. Okay, we're also going to cover them here, so don't stress. We are going to go over it here as well. Okay? All right, my darling. Okay, let's start with the first question. I'm going to change colors here, otherwise we're going to end up coloring the same thing. And if anybody wants to unmute and give me the answers, I'm so happy for you guys to do that. All right, the first question says, in the equation y is equal to mx plus c, the c represents the what? What does it represent? Anybody? No, not 4, not number 4.
The y-intercept.
It is indeed the y-intercept. So the answer C there stands for the y-intercept. So that's number 3. The answer we're looking for there, number 3. All right. It says here, in the equation, y is equal to ax squared plus q. The q represents, okay, which one does it represent there? We know that it's a vertical shift, but what else does the q represent? Number 1 is correct. That's it, number 1. It's the y coordinate of the turning point of the function. Correct. So number 1. Okay, the y coordinate of the turning point. All right. C says the following equation, y is equal to b to the power to the exponent x plus 2 represents, come on guys, I've given you the answer. It's right there. B to the exponent. No, b to the exponent of x plus 2. It is indeed the exponential function. It's number 3. It's exponential. Why? Because our x is the exponent, which means that that's the answer we're looking for. An exponential function. All right. In D, it says here, we're given the equation of the function f of x is equal to 3 over x minus 1. It says here, the y-intercept of the function is -1. We don't even know that. We'd have to calculate that. And it's wrong. It's going to be 3. All right. It says here, the vertical asymptote is x is equal to 0. The horizontal asymptote y is equal to 1. There are no asymptotes. There's only one asymptote. Well, that's true. Oh, no, I'm lying. Why am I lying? There's not one asymptote. There are 2. There are always 2 asymptotes. So the correct answer we're looking for here is which value none of these can be. And we know that the vertical asymptote x cannot equal 0. All right. Then this last one. We are given the function 2y minus 4x minus 8 is equal to 0. Who can tell me what function is this? What function is that? What kind of function are we looking at in E? Anybody? It's not obvious. That's it. Correct, Katleho. It's linear. It's a linear function. So we can't leave it the way that it looks. We need to rearrange it to make sure that it ends up looking the way that we normally know. Because a linear function should look like that. Y is equal to mx plus c every single time, grade 10s. So if you see a question that's written like this, you need to rearrange it to make sure that it's written in the y is equal to mx plus c format. So I'm going to take the negative 4x over, and I'm going to take the negative 8x over, or the negative 8 over. I'm going to end up with 2y is equal to 4x plus 8. And I don't want 2y, I want y. So I'm going to divide by 2 throughout. Okay, so my final function will be y is equal to 2x plus 4. That is the original function. They've just rearranged it. We don't want it rearranged. We want this so that we can answer the question. The question then says, the y-intercept is negative 8. That's clearly a lie because we've now put it properly. The x-intercept is negative 4. That's also false because if we make y equal to 0, our x-intercept will come out as positive 2 or negative 2. The gradient is 2. And the gradient is negative 2. Which one of those is true? We know that it's one of the last two. Which one is it? Number 3 or number 4? Number 3, correct. The gradient is indeed 2. The gradient is 2. All right. So this is a 5-mark question. Comes from one of my own papers. 1, 2, 3, 4, 5. How did we do out of 5? I definitely got 5 out of 5. I know I set this paper. How did we do? Nice one, Jaden. Good. Everybody else 5 out of 5? Well done, Oko. 4 out of 5. I have a feeling it was either the last question or the question on the exponential function. One of the two. One of the two. But these are things that we need to know, grade 10s. They're very important. So make an effort to kind of try and figure out where they are. All right. Well done, guys. That's amazing. All right. Let's get into some actual things that we would see, exam type questions. Let's look at this. Okay. Step number 1, whenever we see such a question, is to read. They give us all of this lovely information because it's important. It's important to know this. Okay. Let me explain why. There was a particular year where, and I think I remember this year specifically because many kids were crying, where one of the teachers, oh, that's an extra question that we can do later. One of the teachers did this. They drew a Cartesian plane, and then they drew this, and then they drew that. Can anybody tell me what kind of function is that? What kind of graph are we looking at there? Take a wild guess, grade 10s. What kind of graph is that? You can guess if you want. Hyperbola would be 2 graphs, wouldn't it?
Exponential.
You would say exponential, right? It looks exponential, except the teacher finished the sum by writing here. The function f of x is equal to f of x is equal to negative 2 over x minus 2, x minus 2 plus 1, where x is greater than negative 2. He drew a hyperbola. He drew a hyperbola, but he only took half of the hyperbola. And off your friends went solving for an exponential graph, and they didn't read the information. And that teacher wants to see the world burn. And half the kids, even the smart kids, got 50%, got 60%. There were tears all around. But it's because nobody read the information. So the first thing we always do is read the information. Half the time, many of you are going to be like, ma'am, this question is incomplete. But you'll find that half the information they've given you is actually in the write-up and not on the drawing. So it's very, very important that we read the information first. It gives us context. It helps us to understand exactly what's going on. So what we're actually doing is we're matching everything we're seeing on the picture to everything that's in the write-up. Make sure that everything is there. Okay, so the question or the write-up says, the diagram shows the graph of g of x is equal to ax squared plus q. First thing you need to know is what kind of graph this is. We know that it's a parabola. They're not going to tell you that. They're not going to be like, a parabola was drawn. No, 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 no. They're just going to give you the formula. Okay. And f of x is equal to mx plus c. That is a linear graph. Okay, it's linear. So we need to know both of these things. Then it says r and s, and then they don't give you the value of r, but they give you the coordinates of s, 2 and 0. There it is. Are the x-intercepts of g, and t, 0 and 8, is the y-intercept of g. Right. Graph f passes through the points r and the points t. Okay, they pass through each other. Okay, let me see. Give me thumbs up or thumbs down. Can we answer these first 4 questions on our own? Yes? Okay, I'm only seeing 2 thumbs up. I'm guessing everybody else wants to give it a try and they're not sure. So what I'm going to do is I'm going to put the questions on the screen and I'm going to let you guys go. If you feel like, hi, ma'am, I thought I could, but no, Colby. Okay, send me a message in the chat and we can quickly see if you're able to. For those of you who know you can get through this question, here is, okay, we'll get to 1.5 and 1.6. But here are the first 4 questions. All right, I'm going to give you guys 4 minutes because that first question is a free mark. I don't know what else to call it. It's 3 things. Sorry, grade 10s. That question 1.3, this should read, calculate the values of A and Q, not G. Okay, just say A and Q. Are we ready, grade 10s? Time is up. Yes? Let's have a look. All right. So we need to understand a couple of things as we are answering each of these questions. We need to understand exactly what it is they're asking of us. Okay, so this first question here says, write down the range of G. Now we know from our notes that the range is the Y values, but the range of G refers to a specific graph. And we know that the G graph is the one that's written G of X. That's the one that we're looking for. So we're looking for the range of our parabola. In this case, we will say that Y needs to be less than or equal to 8 because it's concave down. So less than or equal to 8. Some teachers prefer if you write it this way, if you go Y is an element of all real numbers, and therefore Y should be less than or equal to 8. I prefer this way. I know that some teachers don't mind if you just do that. I know some teachers want you to use set builder notation, or, you know, your teachers want you to use interval notation. Write it however it is that your teachers prefer you to write it. Okay, so you guys can pick which one of those works. All right, then it says, write down the x coordinate of R. Now, we can tell just by looking at it, x is equal to -2. Here's the beautiful thing about parabolas. Parabolas are always drawn in symmetry, meaning that our y-axis is a mirror image. What that means is that this half of my parabola is exactly the same as this half of my parabola. Just everything is inverted. All my x values are the opposite to that. So if I look at the fact that my s value on this side is +2, that means the x value for my r needs to be -2. Thumbs up. Are we all happy with that? Okay. Parabolas always drawn in symmetry. So are hyperbolas. Okay, they're always drawn in symmetry, which helps. All right, then the next part says, calculate the values of A and Q. Now, Q is easy. We already know what Q is. Q is the Y value of my turning point. So I can already say Y, why am I saying Y? I'm kidding. G of X is equal to AX squared plus 8. I can add in here, Q is equal to 8. So now what I need to do is I need to find my A value. Now, what do I know about my A value? That I need to substitute one of these other values in order to get it. I can't use that value. That one doesn't count. It's already been used. So I have to use one of the others, either 2 and 0 or -2 and 0, because that's that point over there. Right, I'm going to give the value that was given to me in case I didn't write that one correctly. I'm going to use S's values. Now, remember, guys, the whole of G of X represents the Y. It represents Y. So I can actually rewrite this as Y is equal to AX squared plus 8. Now, all I'm going to do is then I'm going to go to this particular function that I've been, or this coordinate I've been given. I know that 2 is my X value and 0 is my Y value. And I'm just going to sub them in right over there. So I'm going to replace my Y with 0. So 0 equals A multiplied by my S value, or my X value is 2 squared plus 8. And now all I'm solving for is A, because that's all I have left. Okay, so we're just going to maneuver some things around. I'm going to take the 8 and transpose it, so it'll become -8 is equal to 2 squared will give me 4 times A, so that's 4A. Divide both sides by 4. And therefore, A must equal -2. Beautiful. Yay, well done. Amazing stuff. All right. Okay. Then it says here, determine the equation. 1.4 says, determine the equation of F. the equation of f. Now, f, if we go back to the instruction that they've given us, f is our straight line. Okay, so if we want to determine the equation of f, we need to use f of x is equal to y, mx plus c. We need two things. We first need the gradient, and we also need our y-intercept. Our y-intercept, nice and easy, nice and dandy. We already know that it's 8. That's our y-intercept of our straight line. So I can already sub that into here. I'm going to run out of space. I'm going to answer it over here. I'm so sorry, grade 10s. I always write everywhere. 1.4, I'm going to say f of x is equal to mx plus 8. Right. I now need to find my gradient, which means I need 2 points that go past my graph. Luckily, I know that r, which also touches my graph, is the point -2 and 0. I'm going to use these 2 points to find the gradient. So I'm going to go m is equal to, I'll just label them. I like to do that. I'll go y1. Ooh, y1. Shush, teacher Coco. x1, y1. And x2, y2. And we're just going to sub those two in. My gradient is y2 minus y1. So 8 minus 0 over 0 minus -2. That will give me 8 over 2, which is equal to 4. Therefore, f of x is equal to 4x plus 8. There we go. All right. How did we do, guys? Did we manage? Was there any question that was really difficult? Nothing really? Nothing really. Some of it does. Okay. Question 4. Oh, I'm sorry, Mamelo, but we're going to do a couple more of these as we go along. All right. So don't stress too much. We will get into doing this a little bit more. Okay. I'm going to call it. We're going to call it. We are going to continue with some of this stuff. We're going to do different, we're going to do a bit of different stuff as we go. I know, I know, Desmarie. Time goes so fast when we're doing these sums. Okay, but if we want to really get in on these questions and understand what we're going to do, I would really, really suggest you come to the boot camp, okay? Because in the boot camp, I'm going to start breaking things down one at a time.